I'm going to show you how you can find the trig value when you are given a point. Now, for this, I want to do a little background so that you understand where this comes from. What we're going to do is we're going to look at a triangle that's in a coordinate plane that's also inside of the circle. That's a really horrible circle, but just work with me. So this is our right triangle that we have. Okay, this is our radius. That's also the radius, or this is our hypotenuse. That's also a radius of the circle. Okay, so if we look, this is our x value, this is our y value, and we're going to call this r for the radius since we're looking in terms of the circle. So if I label this as my theta, if I look in terms here, the sine of theta, if we label our triangle like we used to, this side is the opposite, this side is the hypotenuse, and this side is the adjacent. So remember, sine is really opposite over hypotenuse, but in terms of our x, y, and our r, the sine is y over the r. Now, the cosine of theta is going to be the adjacent over the hypotenuse, but the adjacent is really the x, and the hypotenuse is really the r. Then the tangent of theta is the opposite over the adjacent, but in this case, with our x and y's and r's, it's going to be the opposite, which is y, over the adjacent, which is x. So we end up with y over x. So I have a way to try and help remember this. If you like it, great. If not, then think of your own way. But you can think, it's this little sentence to help you remember. So each word that or sound that we begin with is what it starts with. So y, sin, 'cause it's extra fun. Take your extra fun and go. Okay? And then your sine and your cosine are both over your radius. When you're looking at your unit circle and you have a radius that's a length of 1, then it simplifies to your sine is just y, your cosine is x, and your tangent is y over x. Okay? Now, you can do these kinds of problems by using this information and the fact that your r, if we look at the Pythagorean theorem, it would be the x squared plus the y squared, and then that equals r squared, but if I want to find r, I would just take the square root of that whole thing. So I can use this and this part right here for when you're given a point and you want the sine, cosine, or tangent. So let me give you an example. You can also draw it and figure it out using your knowledge of sine, cosine, and tangent from just trig with your opposite, hypotenuse, and adjacent. So if I give you, I want to find the cosine of theta, and the point is -4, 2 root 5. So the instructions will say something like, use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. Okay, so this point is located on the terminal side, which means that it's on the ending side of the angle. So -4, 2 root 5 is going to be someone over here. Like, just like we have our normal 1, 2, 3, 4, and then our 2 root 5. If you wanted to, you could find 2 root 5 in the calculator and see that it's 4.47, so 1, 2, 3, 4, and almost 5, right? So this would be where my point was specifically, right? But you don't actually have to draw it out very specifically each time. So this is our theta that we have. This is the terminal point, or a point that's on the terminal side, and it wants to find what the cosine is. Well, remember, the sine, cosine, and tangent for any angle is the same as its reference angle. So if we draw this triangle right here, this is really our reference angle, right? So if I create this right triangle here, this cosine of this triangle would be the same as the cosine of this angle. Okay? So, like I said, we can label our triangle, draw a picture, and help us get what we need. So this is -4, and this is 2 root 5. So now what I'm going to do is find the radius. Okay, so to find the radius, I'm going to do negative 4 squared plus 2 root 5 squared equals r squared. Okay, now we can put this whole thing in the calculator. I'm going to do negative 4 squared. Make sure you put the negative in parentheses. If you don't, what your calculator does is square it first, then multiply it by a negative, which is not what we're trying to have the calculator do. Plus, I'm going to put my parentheses and do 2 root 5, close my parentheses, square it, and I'm going to take the square root of that, so 36 equals r squared, so then r is just 6. Okay, so our radius here is 6. Now, if we hadn't drawn this picture, you could still do this part without the picture using the fact that r squared is x squared plus y squared square rooted, right? So you don't have to draw the picture, but drawing the picture can help you see what our picture length is, or what the lengths are on the picture. Notice if we were to label our triangle, that we would have, this is the opposite, this is the hypotenuse, and this is the adjacent. So if I go for the cosine, I would have adjacent over hypotenuse, which would be negative 4 over 6. So that means oh no, we found 6. So I would have negative 4 over 6 for my cosine. Okay, or remember that the cosine was the x value over the r value. Well, x is this point. Remember, this is x comma y, so x is negative 4. And then the radius that we just found here is the 6, which then we can reduce to be negative 2/3. Okay? So that's how you find a ratio when you're trigonometric ratio when you are given a point that's on the terminal side. Okay, so let's try another one. Okay, so if I have oh, let's do this one. This one's nice. The cotangent of theta for 2, negative 17. Now, remember that the tangent of theta was y over x. Okay? Well, notice this is our point x comma y. So if I want the cotangent is just going to be the reciprocal of this. So we're going to look for x over y. Well, I don't even have to find r in this case, right? Because I don't need r to find my cotangent. So I'm going to do 2 over negative 17, but it's a little bit abnormal or unconventional to have the negative in the denominator, so I'm just going to write it as 2/17. Okay? And then that's my cotangent. Now, let's take a look at doing it one more. So if I have, let's do the secant of theta, and we're given the point negative 6, negative root 13. Okay? So let's do it first without a picture, and then I'll show you with the picture what it would look like. Okay? So remember that your r squared is x squared plus y squared, which is the same thing as r is x squared plus y squared square rooted. These two are the same thing. This one's solved for r, this one has r squared. Okay? So to find my r value, I'm going to do negative 6 squared plus negative root 13 squared, all underneath the square root. So because we like to have square roots in their simplified form and not as a decimal, in the calculator I like to put what's underneath the radical. So I'm going to do negative 6 squared plus negative root 13, close my parentheses, squared. Notice the roots outside the radical on my calculator as well. Okay, so I get 49. In this case, it's a nice square number, so I get, or has a perfect square, I should say. So our r value is 7. The secant goes with cosine. Cosine is y sin cos, it's extra fun, so it's the x value over the r value, but we're going to flip that. So the secant of theta is going to be r over x, which means that I have 7 over the x value. Remember, this is x comma y, so I have 7 over negative 6. Like I said, it's abnormal or a little bit unconventional to have the negative in the denominator, so I'm going to rewrite it as negative 7/6. Now, if we were to look at the picture, negative 6, negative root 13 would put me in this third quadrant. This is negative 6, this is negative root 13. This angle would be the angle that you're looking at. That's your reference angle, even though this whole thing is the angle. But remember, the sine, cosine, and tangent of reference angles, or secant, cosecant, and cotangent of reference angles are the same as the original angle. So now that we found that this is 7, right, this is the opposite, this is the adjacent, and this is the hypotenuse. The secant would be the hypotenuse over the adjacent, which would be the 7 over the -6, which is what we got. So you can do this entire process without drawing a picture, but if you like your picture, feel free to use the picture to help solidify or just to get your answer. And that's how you find the trig ratio given a point that's on the terminal side. So once again, your instructions would be use the given point that's on the terminal side of angle theta to find the trigonometric function indicated. Okay, something like that. And that's how you do that.